The goal of this video is to teach you how to simplify trigonometric expressions. So on the right here, we have our three Pythagorean identities that will come into play when simplifying these expressions. Now, if you don't know these, how to derive them, there's a separate video for that that you can click on at the end of this video. But our goal is to solve and simplify these trigonometric expressions. Now, if you already know how to do this and you came here for extra practice, why don't you go and pause the video and try doing this one on your own. If not, and you want some help with this, let's check it out. So whenever you see a trig function squared, so I see cosine, that's a trig function, and it's being squared. You want to go back to your Pythagorean identities. And if you look at this top equation here, we have cosine squared theta here. Now I can see that if I were to solve this top equation for sine squared theta, if I were to get sine squared of theta by itself, I would subtract cosine squared theta to both sides of the equation. So let me just show you that right here. Let me move these for a minute. I'm going to subtract cosine squared theta to both sides of the equation. And I get sine squared theta equals 1 minus cosine squared theta. So see where I have 1 minus cosine squared theta here? We can replace that with sine squared theta. And see how I have 1 minus sine squared theta? So whenever you see a trig function squared, you want to go back to Pythagorean identities. And back up here, if I were to solve for cosine squared theta, if I were to get this cosine squared theta by itself, I would subtract sine squared theta to both sides. So if I subtract cosine squared theta to both sides, this would become 0. I have cosine squared theta equals 1 minus sine squared theta. Now this 1 minus sine squared theta, I can see that right here. I'm going to replace that. I'm going to use substitution and replace it with cosine squared theta. And this is equal to tangent squared theta. If this question is on the College Board exam, they might ask you to simplify this expression and write it as the cotangent function. Well, then the answer would be 1 over cotangent squared of theta. Or if they just ask you to write this expression as tangent of theta, then your answer is tangent squared theta. All right, here's our next example. So if you want to try this on your own, go for it. You can pause the video. All right, now when I see secant squared of x, I need to think back to, I see a trig function squared, I need to think back to our Pythagorean identities. I can scroll up, but it would be great if you know that 1 plus tangent squared x equals secant squared x. Again, I derived those in another video if you want to see how those are derived, but you can see it's right here. This equation right here, I have theta in this equation. Theta represents an angle. X represents an angle in this instance here. Now, see how I have secant squared x minus 1? If I can get secant squared x minus 1 by subtracting 1 to both sides of the equation, oops, I'm going to subtract 1 to both sides of the equation. We'll get tangent squared x equals secant squared x minus 1. So this is great. I see secant squared x minus 1 here, and I see it right there. So I'm going to replace secant squared x minus 1 with tangent squared x. Divided by, I have this tangent x right here. So tangent squared x divided by tangent of x, that result will be tangent of x. If this question is on the College Board exam and they ask you to rewrite this expression as the tangent function, your answer is tangent of x. If they say rewrite this as the cotangent of x, this would equal 1 over cotangent of x. All right, our directions here are just to simplify these expressions, so this is our simplest form here. Another example here, if you want to pause the video, give this a shot. All right, so I see sine of theta and secant of theta, and right now I do not see any trig functions squared. So I'm not going to go back up to these Pythagorean identities here. Only when I see a trig function squared will I be considering those. Now, sine of theta times secant of theta. I know that secant of theta is the reciprocal of cosine. So I can rewrite this as times 1 over cosine of theta. So you need to be familiar with that secant of theta is the reciprocal. It's equal to the reciprocal of cosine of theta, which is 1 over cosine theta. Now I'm going to write this as, well, I have that there, divided by tangent of theta. So I'm going to leave this denominator the same for a moment. All right, it would be great if you know that sine of theta times 1 divided by cosine of theta will just give us tangent of theta. So this numerator becomes sine of theta over cosine of theta, which is tangent of theta. And in blue there I have highlighted tangent of theta. And this is great. So tangent of theta divided by tangent of theta is equal to 1. Alrighty. So this next question here, our directions are still to simplify this expression. If you want to pause the video, give this one a try on your own. All right, so we see 1 minus sine squared of theta. Whenever you see a trig function squared, you should think about the Pythagorean identities. So I know the cosine squared of theta plus the sine squared of theta is equal to 1. So when I subtract sine squared theta to both sides, I'll get cosine squared theta equals 1 minus sine squared theta. You know, eventually you'll do this enough where when you see 1 minus sine squared theta, you'll just recognize that that's equal to cosine squared theta. Okay, now some of you might be thinking, all right, there's a trig function squared here. He said to go back and look at Pythagorean identities. Oh, good point. That's only if it's like a 2 terms here. I want to rewrite it as 1. So I'm really content right now with these both being a term cosine theta squared in the numerator and cotangent squared of theta in the denominator. So I don't want to go back and look at the Pythagorean identities. I just want to rewrite cotangent squared of theta. So I'm going to write cosine squared of theta. Now, it'd be amazing if you just knew that cotangent squared of theta is the reciprocal of tangent squared theta. And so I can literally just write tangent squared theta here. If that's a stretch for you, I could derive that by multiplying by tangent squared theta over tangent squared theta. And tangent squared theta times cotangent squared theta would be 1. Those are reciprocals. Another way I could convince you of this is I'll write this as divided by. So I have cosine squared theta here divided by cotangent squared theta. And then I can rewrite cotangent squared theta as cosine squared theta over sine squared theta. And when you're dividing by a fraction, it's the same thing as multiplying by the reciprocal. So I'm multiplying by the reciprocal. Oops. All right. Boy, that was the long way about of showing. See this sine squared theta over cosine squared theta? That's equal to tangent squared theta. So it'd be great if you knew that 1 over cotangent squared theta was equal to tangent squared theta. And I could rewrite that. Otherwise, I showed you all the work here. This is cosine squared theta, and this right here is tangent squared theta. So in this step, I'm going to rewrite cosine squared theta times sine squared theta. over cosine squared theta. It's one of the things you need to know is that tangent of an angle is equal to the sine of the angle divided by cosine of that same angle. Now this is great. I can cancel these factors here, and the result is sine squared theta. Now if this question's on the College Board exam, in the free response, they might tell you to take this expression and rewrite it, simplify it, so you see the cosecant of theta. And it's like, what? We have sine squared of theta. So sine squared theta is just equal to 1 over cosecant squared theta. So that would be your answer if the direction of the College Board exam said to rewrite this, simplify this expression, so you only have the cosecant squared of theta. And so this would equal, sine squared theta is equal to the reciprocal of cosecant squared theta. All right, here's another one for you. Maybe if you didn't have more confidence, or maybe you didn't have enough confidence before, you have more confidence now to try this problem on your own. So feel free to pause this video. All right, I currently do not see any trig functions squared. Now, I do know that cosecant theta and sine theta are reciprocals. So when you multiply reciprocals, the product is 1. You know this, like 2/3 and 3/2, those are reciprocals. And when you multiply those, you get 6 over 6, which is 1. You know that the reciprocal of 4/5 is 5/4. And so when you multiply reciprocals, you get 20 over 20, which is 1. So I have complete confidence that sine of theta and cosecant of theta are reciprocals. So when you multiply those, you get 1. I would love just to say it's 1 over cotangent of theta. But if you still aren't tracking what I'm saying, we take this numerator here. I hope you know that cosecant theta is the same thing as 1 over sine theta. So I took cosecant theta and rewrote it as 1 over sine theta. And now maybe is the moment that you realize, oh yeah, he's right. Sine of theta times 1 is sine theta. Divided by sine theta is 1. Otherwise, these are reciprocals. When you multiply reciprocals, that product will always equal 1. And now, so if the College Board said, hey, write this expression, simplify this as cotangent of theta, that's your final answer. I would prefer to write this as equal to the tangent of theta. So this right here says the reciprocal. This is equal to the reciprocal of cotangent of theta, which is tangent of theta. All right. Next problem here. Feel free to pause the video if you want to practice it. So we see trig functions squared here. So that makes me think of our Pythagorean identities. So hopefully you can derive these, and then maybe at this point you've memorized them. 1 plus cotangent squared x is equal to cosecant squared x. So I see this cosecant squared x, I see this 1. I'd like to subtract 1 to both sides. Then this will be, this will be cotangent squared x equals cosecant squared x minus 1. So cosecant x squared minus 1 is there and there. So I'm going to replace this with what it's equivalent to, cotangent squared x. Now again, when I see a trig function squared and I see 2 terms here, that's when I want to go look at our Pythagorean identities. Yes, I see trig function squared, but I love it's just 1 term in the numerator and 1 in the denominator, so I don't want to go rewrite these by looking at Pythagorean identities. I want to just consider what is cotangent squared of x. Cotangent squared of x, so I'm looking at this numerator here, is equal to cosine squared x over sine squared x. Okay, now see this divide symbol? I prefer to rewrite it like this, divide. I'm sorry, divided by cosine squared x. So we have cotangent squared x, which is here, divided by cosine squared x. And now, when you have a term divided by cosine squared x, I can multiply by the reciprocal. So this is cosine squared x over sine squared x times 1 over cosine squared x. Now this is great. I can cancel these factors. Factors are separated by multiplication. So here I have cosine squared x times 1 divided by sine squared x times cosine squared x. So I can cancel these factors. Our result is 1 over sine squared x. Now that is also equal to the cosecant squared of x. So we should be familiar with that 1 over sine of x is equal to the cosecant of x. All right, feel free to pause the video if you want to try this one on your own. All right, so I'm not seeing any trig functions squared right now. This is kind of strange, seeing cosine of theta over secant of theta. So I know that 1 over secant theta, see how the secant theta is in the denominator there? That's equal to cosine of theta. This kind of goes back to that previous problem. If you wanted to, the reciprocal of secant is cosine of theta. So you can multiply by, I don't know if you want to show this step, if this makes more sense to you, is we could multiply by cosine of theta over cosine of theta. You're allowed to do that because cosine of theta divided by cosine of theta is just 1. So multiplying this term by 1 changes the way it looks. And so cosine of theta times cosine of theta is cosine squared theta. Now secant of theta and cosine of theta are reciprocals. Remember we talked about before, when you multiply reciprocals, that product is always 1. So this denominator will be all over 1. Now I love it if you just knew that 1 over cosecant theta is equal to sine of theta. So I can just write sine of theta here. I'll show you. Just like over here, we can multiply this by sine of theta over sine of theta. That's an option. Sine of theta times sine of theta is sine squared theta. Cosecant theta and sine theta, we need to know those are reciprocals of each other, so that product will be 1. So here, cosine theta times cosine theta, this is the notation. It's cosine of theta squared. You write it like this. Otherwise, it'd be parentheses cosine theta and parentheses squared. Plus, I could write it like this. This is sine of theta all in parentheses squared. That's what this means. But this is also, looks different. It's just different notation, but it means the same thing. Now you should recognize this. See how you have trig function squared and you have 2 of those terms? We go back to our Pythagorean identities and you should recognize that as, here it is, cosine squared of an angle plus sine squared of that exact same angle will output 1. So our solution here is 1. All right, this will be our last one to practice. So why don't you pause this video and try this one on your own. All right, so I see these 2 terms here in the denominator. 1 minus cosine squared theta. So I want to, since I see 1 minus cosine squared theta, I want to go back to our Pythagorean identities. Hopefully by now, maybe it's going to take more time, but when you see 1 minus cosine squared theta, hopefully you recognize that's equal to sine squared theta. So we have sine squared theta is equal to 1 minus cosine squared theta. These two terms are exactly the same two terms there. So I'm going to replace them with sine squared of theta. Okay, now I have sine of theta times cosine of theta. Those are your factors in your numerator. And I have sine of theta times itself. So I have sine of theta squared there. So I can cancel one of those factors of sine of theta, and I get cosine of theta over sine of theta. That is equivalent to the cotangent of theta.